Alright guys, in the last video we introduced you to the law of sines and proved it using a regular triangle. It wasn't a right triangle, it just had random lengths and random angles. What I want you to know is prove the law of cosines and show you that you can use it in a lot of different word problems that you may encounter while you're doing trig. So let's say I already drawn a triangle right here, and let's say that I know this angle to be theta, and I know this angle is angle theta, and I know that let's say that this side would be side B, and let's call this second side side C, and the last side will be obviously side A. So, if this was a right triangle, we could have easily used the Pythagorean theorem to solve for the sides. But since this triangle, unfortunately, is not a right triangle, we cannot use it. So, what are we going to do? Let's assume that we know B, we know C, and that we know theta, and we want to solve for side length A. But in general, as long as you know three of these four values, the three sides and then an angle, you can solve for the fourth once you know the law of cosines, which I'm gonna here again prove in this video right here. So how can we do it? We're gonna do it similar to the previous proof that I put up, the law of sines. Let's say we can drop an altitude here. Whoops, that line's a bit crooked. Let's try that again. We can drop a line from this vertex right here that creates two right angles with side length C. So right here I have right triangles, and now I can use pretty much basic trig functions and the Pythagorean theorem to solve. So let's see here. This angle right here is a right angle, and so is this. So what is this side right here? What would be the length of that side, the purple side? So again, we will write circa TOA at the top in order to solve for the purple side and pretty much everything else that we need to find out in order to solve for A. So we know that the purple side is adjacent to theta, and side B is the hypotenuse of this right triangle right here that we formed using the amplitude, not the amplitude, sorry, the altitude. So we know that cosine of theta, and let's just call this subside here d. So we know that the cosine of theta is equal to d over b, which then is, if you want to solve for d, then it would be d is equal to b times cosine of theta. So let's call this side right here e. What would the value of e be? So you know that e is just equal to the value of c minus the value of d, which is pretty much common sense. And therefore e is equal to c minus d. And since we just solved for d right here, which d is equal to b cosine of theta, we can just plug that in for d, and the value of e would equal c minus b cosine of theta. So this magenta colored side, the height of the triangle, or the altitude that I dropped earlier, what would that length be? So let's solve for that. So let's call this side m. M is opposite to theta, and therefore we would use sine, because we know the opposite and then the hypotenuse, and therefore m over b would be equal to sine over theta, because again b is the hypotenuse. or that this would also simplify to m is equal to b sine of theta. So now we have figured out m. We figured out e, and we want to figure out the rest. So we want to figure out a. And since we have two sides of the smaller triangle, right triangles, we can use the Pythagorean theorem to solve for a. The Pythagorean theorem tells us that a squared is equal to n squared plus e squared right here. So, well, what is n squared plus e squared? So, a squared is equal to b sine of theta squared plus e squared, which is equal to c minus b cosine of theta quantity squared. So, let's just do some simple simplification in algebra, and after a little bit of work, we will end up with a squared equaling, let's see here, b squared sine squared of theta plus c squared minus, let's see, what would that be, 2c times b times cosine of theta plus b squared cosine squared of theta. So this would equal, if you just simplify it, b squared sine squared of theta plus another b squared cosine squared of theta plus c minus 2 bc cosine of theta. So these two values of that I stated earlier, the b squared sine squared of theta and b squared cosine squared of theta, can be simplified to b squared times sine squared of theta plus cosine squared theta, which it probably sounds familiar, is one of the basic trig identities. And one of the basic trig identities says that sine squared of theta plus cosine of squared of theta is equal to 1. So therefore, after all this math, the value just equals b squared. And then you can simplify it even further, so it would be equal plus c squared minus 2bc cosine of theta. Again, sine squared of theta plus cosine squared of theta is equal to 1. Again, the same trig identity. As a result, we are left with a squared is equal to b squared plus c squared minus 2 times b times c times cosine of theta. That's pretty much it. I mean, that's pretty neat, and what we're left with here is known as the law of cosine.